Okay, now we're going to look at the topic on quadratic inequality again. Okay, but this time we are going to use number line. Okay, to find the range that meet the requirement, whether it's bigger than 0 or smaller than 0. Okay, now let's look at the first case whereby it's more than 0. Okay, now let's look at this quadratic function here. 2x2 plus x minus 15 bigger than 0. Okay. Make sure everything on the right hand side is bring to the left hand side, making the right hand side a 0. After that, you factorize this. Okay, factorize this, and from here, for this to bigger than 0, this either is this bigger than 0, so we put it here, or this is bigger than 0, we put it here. Okay. Now, so simplifying this, let's look this case. This is x more than 2.5. For this to be bigger than 0, x must be bigger than 2.5. So the red color one, that is how we draw the number line. The red color, it is an x number line. So anything more than 2.5 here, more than 2.5 is positive, bigger than 0. Okay. Anything less than 2.5 will be negative. So from here onward, all the way here is negative. Okay. Now let's look at this part here. X plus 3 bigger than 0, bring it over. So x, it must be more than minus 3 for this whole thing to be bigger than 0. So what we do is we put minus 3 over here. Look at the yellow line or the yellow line. So for this to be bigger than 0, x must be more than minus 3. Okay, more than minus 3 means this direction. So this is positive or this is positive. And if it's less than minus 3, then it will be negative. Okay, now, but remember, this function here is a product of this and this. Okay, it's a product of this and this. So to determine the final value of x, for it to be bigger than 0, we have to do a combined effect of multiplication. Okay, so look at positive times positive, positive times positive, we give a positive. So this range here, anything more than 2.5 will give you a positive value after the multiplication. Now, what about here? From 2.5 to, from minus 3 to 2.5. Over here, this is negative. Over here is positive. So positive times negative, negative times positive, still give you a negative. So this is less than 0. Okay. Now, this case here is negative times negative, negative times negative, give you positive. So this side here, so that means anything less than minus 3 give you a value of more than 0, which is positive. So the final answer would be x must be less than minus 3. Okay. And then x must be more than 2.5. Okay. For this whole function here to be more than 0. Okay, this is another way of looking at it. What about if d is less than 0? If this is less than 0, let's draw the line, draw the number line. X. Okay. Now, let's use this as 2.5. Okay. For this to be less than 0, x must be less than 2.5. So what it means is for this to be less than 0, so f has to be less than 0. So for this to be less than 0, x must be less than 2.5. And say this become negative, then this one become positive. Okay. Now let's look at -3. Now for -3, for this to be less than 0, x has to be less than -3. That means to say this direction, x have to be less than 3 for it to become less than 0. And this one is negative. This one all the way here, this is negative. Now, so if you have more than, if x is more than -3, then this whole function will be more than 0. So this becomes positive. Okay. Okay. Now, so negative times negative, you get a positive value because this is a product. This times this, and then positive times positive becomes positive. But what this we want less than 0. If less than 0, then for it to be less than 0, is this times this. I mean minus times plus equal to negative. Therefore, for it to be less than 0, the x value must be within from here to here. So x must be more than -3 or less than 2n.